Hi, everybody. Thank you for coming out here this morning. I know this is the first talk of the game session, so I hope you're all coffeeed up and ready to go. We're going to talk to you about developing games with Firebase. My name's Patrick Martin, and I am a developer advocate with Firebase for Games.
And I'm Justin Broughton. I'm the engineering lead for Firebase Test Lab.
And I'm Jon Skrip. I am a software engineer with Google, specifically working on the Firebase growth team. So
right.
with that, we'll let Patrick take it away.
Well, we have a brief map of where we're going to go today on a kind of a fun adventure. I will talk about building games with Firebase.
And I'll talk about the exciting adventure of testing games with Firebase.
And then I will talk about growing your game with Firebase. And now we will let Patrick take
now
it
you're
away.
free to go.
We'll let him go.
Just one more brief piece of bookkeeping. We're only going to skim the surface of Firebase today. If what we talk about sounds interesting to you, we'll be right back there with Mecha Hamster, so you can ask questions, as well as there's a Firebase tent over there. So with that, let's get to building games with Firebase. So I want to give you all a little bit of my background. I started about a decade ago making mobile social games. And then I eventually got into prototyping with actually robot toys. And typically, I find that the tool set for each of these is normally astoundingly different, right? With a prototype, you just care about getting to the next checkpoint, getting like approval to work on it more. Whereas long-standing like ship titles need to be accessible from all over the world at all times of day. And there are just different considerations. But I think Firebase is really good at bridging the gap. So as game developers, as I assume many of you are here today, as game developers, we do not have the luxury, right, of just looking at a game design document, implementing everything by the letter, and hoping we get a good game out at the end. We're always questioning what we do, and always trying to make sure that what we built is fun and interesting. And I think Firebase helps because it shortens the distance from that idea you have that you want to test to the implementation and experimentation that will tell you whether or not it's something you want to run with. And even though it gets a lot of the back-end architecture stuff out of the way, but if for whatever reason you find that we've made the wrong abstractions for your particular situation, Firebase is a Google Cloud product, and at any point, you can switch over to the Google Cloud dashboard and just pick up right from where you left off and build out whatever you need. But I'm going to focus today actually on using Firebase and trying to show how easy it is to work with by augmenting the single-player game called Mecha Hamster. This is an open-source project. Again, we have it back there in the garage that we use as our testing ground for every new feature we add to Firebase for Unity. It's a very simple game. You tilt your phone to get Hammy the Hamster over here to the end of this maze. A lot like those wooden marble mazes you probably played with as a kid. Let's see. So what we're going to do is add a level editor to this game. There are a lot of reasons to do it. One of them is so I can talk to you guys up here about Realtime Database. But also, it will help improve the developer experience. Let designers to build a level, then test it immediately just by clicking this play button. And also, I'm based out of Colorado. And a lot of my coworkers are out in California, or out here. So it'd be really awesome to have the share button so they can send a level to me immediately and get my feedback without having to wait for like the build server to kick something out. So of course, we used Realtime Database. This is really neat, to me at least, because it represents all of your data as a large JSON document, which Unity has built-in serializers to and from. So there's not much custom code to write to support this. It's synchronized in real time, as its name probably implies. As game developers, I should warn you that this is not real time like Quake 3 dedicated server. I'd recommend checking out Agoni's for something like that. But if your experience can be like Google Docs, multiple people working in one document, this is a perfect tool. Or it'd be awesome for asynchronous multiplayer games. It's also cached. If you've worked on these kind of mobile, social, whatever sort of game, you probably have experienced all the annoying corner cases around the user went into a tunnel and did something, right? So everything you do is cached offline as transactions. You can query the database immediately to see what your current state is. And when you reconnect to the internet, rather than just replacing the data on the server with your local copy, you replay the transactions that got you there. That way, if you're storing score, for instance, you don't just replace a potentially higher score with a lower one you have on device. You just add 10 points, or whatever the Lambda function is you provide to the transaction. And there's something else. I am a front-end dev, and I get super nervous when it comes to exposing back-end stuff like this to my users. So it would be really awesome if Firebase had some way to let me securely share this information without without a lot of the nervousness that comes with writing custom server code. For that, we actually have a verbose rules.json file that you can store next to your database. This is a JSON document, and right here, this is a small snippet. I'm saying that the map list, so all the maps in the game, are readable by anyone with this database URL. But with a small change, I can restrict it to only authenticated users. Now, you may realize at this point it's still not secure, but since this takes a JavaScript-like syntax, you can do something like store the UID of the creator of a map in that map node and verify it here. And you know it's running on a secure server in a way that an attacker would have a really difficult time spoofing credentials. And this comes from something called Firebase Authentication. In MechaHamster, we opted to use email address and password as our authentication mechanism, as well as something called anonymous auth, which I know sounds a little weird, but all anonymous auth is a unique identifier associated with a combination of game and device. So the same game across multiple devices has different identifiers, as does different games on the same device. But it's a really nice way to just give your users an easy single-click button to access your online components, knowing later that they want to migrate up to a different auth method. So I mentioned that we use email address and password. This is not me rolling my own auth system. This is a product from Firebase. It just has credentials unique to your game. But we also support all of these other identity providers. And as I mentioned, they support merging and migrating accounts. So Game Center, for instance, is a new integration. If you have an existing Firebase game on the market using authentication, you can just integrate the Game Center client SDK, turn it on in the Firebase Cloud Console, and then prompt your users to merge their account with the Game Center one. And now they have that one-click experience that your iOS game players probably expect from other games, just seamlessly integrated to your own. Now, I would love it if all of you got really wild up and ran home and used Firebase right now, right? But I know that that's unreasonable, and it's even hard for me to hand you this open source game and say, look at it and decide if this is right for you. So we created this project called Unity Solutions on GitHub. And in particular, we have this Firebase Leaderboard solution. This implements a leaderboard, which many games require one of those, directly on top of Realtime Database. So you can try Firebase in your own project, in your code base, and see if it's right for you. And if it's not, it's really easy to take out a leaderboard. But at least I think it's really fun, and you'll get a kick out of using this. And as I mentioned, we test everything in MechaHamster, including the code path that all of you would use if you integrated this Firebase Leaderboards. And in particular, since it's open source, we want you to expand upon it. So we in MechaHamster decided to try adding a replay system. So you see how someone got that really awesome 2-millisecond score on Easy Breezy, right? Obviously, the naive approach, what I might do when I first approach this problem is just hit the data I have in memory for the replay with Unity JSON serializer and try to drop that into the real-time database. But at some point, this database isn't real-time just because there's so much data you're trying to send over the wire. In this case, in a protobuf, which is the format we're using, this is 30 to 60 kilobytes. You can probably easily double that for a JSON file. So we decided to use cloud storage for Firebase. This is a key value storage solution. It's another kind of database that lets you store a key, which is just a string path, as well as any arbitrary binary blob. So in our case, replays, but it could be player avatars, videos. If you wanted, you could probably even put like APKs and binaries up there. And our flow becomes, when you get a high score, log in the leaderboard, but at the same time, start uploading the replay data to cloud storage. You get a callback when that completes asynchronously, and at that point, we can store a reference to the file we just uploaded in a new node we added to the RTDB. There is still one other problem. Now we have high scores in 2 locations. If you're like me, most games I've shipped with a leaderboard, I've been on it at the point I click the publish button. I might have even had the highest score on a particularly small game. But within the hour, I'm just gone by like an order of magnitude, right? It would really stink if I was always paying for that cloud storage space for this replay, effectively from day 0 for the rest of the game's lifetime. And you can't really rely on user clients to behave well and clean up all this data as a new score goes up. Even in the best case scenario, someone's phone might just stop working, like they drop it in the ocean or something in the process of uploading a score. So we use cloud functions to listen for when a node is added to some path in the high scoreboard, and then perform our cleanup. In this case, check to see if there are more than 5 high scores, and get rid of the associated replay data. Now, cloud functions, they're brand new out of beta, and they let you run mobile backend code without managing servers. They're written in JavaScript or TypeScript, and they're also secure. Just like Realtime Database, if you create something called a callable function, you get and use our SDK to integrate it with your client app, you'll automatically get the user's login credentials, and they're pre-verified by the time your code executes. And not only can you communicate between different Firebase products, but you can also communicate between Firebase and the rest of the internet. So if I were to try to call out some use cases that you might want to use in a video game, could be if you're making board games. Let's say you're making a Monopoly Battle Royale, right? Someone's going to figure out how to always roll doubles in jail. So roll your die in a cloud function very easily, store the result in a real-time database. You've mostly eliminated the potential of cheating. If you have gacha mechanics, a lot of games now have loot boxes for monetization. Some user is going to figure out how to make every loot box a Gallahorn if you let them claim what their prize is. So again, roll it in the server, distribute it through real-time database or some other mechanism, and you have control. Later on, Jon's actually going to talk about another product called Crashlytics. You can listen for when a new crash happens, and automatically log a bug in Jira for your team. You can even get a callback when a bug spikes in prevalence, and send an SOS to your team's Slack to be like, hey guys, drop everything, and take a look at what's happening all of a sudden.
All right. So, Patrick, we were talking off stage about some of the horror stories that you experienced while developing games. What are some of the most horrible things that you ran into?
I mean, there was a time when I dropped a game from 5 stars to 1 overnight.
Which I'm sure you were popular when you did that.
that was a hard week. There was also a time when a producer on a contract product I was working on actually managed to get my phone number at midnight and called me with an issue where I was getting a blank screen on only a device his friend had. But of course, it was the contractor or contractee. So he had the final say in whether or not our game was approval ready. So I ran through, tore through our entire device inventory, could not reproduce it. I was there until people started showing up the next morning.
So if only you'd had access to Firebase Test Lab, which is perhaps the most contrived segue ever.
You still earned this.
Thank you so much. All right. So we're going to turn our attention to testing games with Firebase. And so for all you games testers out there, when we test games, what are we looking for? Well, in some respects, games are just like applications. So we're looking for signals. which might indicate a problem or a bad experience, such as slow startup time. We're looking for crashes, which give a particularly bad experience to the user. We're also looking for incorrect behavior when the app or game does not behave as we intend or as the user expects. But games are different in the sense that we care about the rendering performance. That is because games provide an immersive experience that is seriously damaged if the rendering is janky or slow. So what are devs doing today around testing? Well, from talking to many of you, there's a whole hell of a lot of manual testing going on. There is some automated testing, but it's generally homegrown, so it doesn't work outside of the game engine that you're using, or indeed out of the company in which you work. So the question is, why do we care? Well, obviously we care mostly because of the expense. Training all of those testers to get to some of the late levels in your game, and then manually testing across a variety of different devices and verifying the results is pretty expensive. And then the testing needs to be repeated on every single release of your game. The testing's also done late, which means you don't find the problems early when they're cheaper to fix. And lastly, there's no safety net for your developers, which means that they've no idea if any change they're about to make is going to break the game in some fundamental way. So why are games devs not flocking to automated testing? Well, as it turns out, testing games is pretty hard. Firstly, games are rendered with OpenGL or Vulkan or some other opaque framework. So the testing tools that you can use for apps like UI Automator, XUI Test, Espresso don't work for games. Games also offer a wider array of inputs. You can imagine games like World of Warcraft or Clash of Clans, where you're basically placing your characters or building your towers anywhere you like on the screen. So the number of inputs is virtually infinite. Games are often deliberately unpredictable. This is because we want to give a different experience to the user every time they play the game. And often, the issues within games are really hard to reach. You can imagine that your favorite ogre on level 10 is dying, and you've no idea why. So up until quite recently, the only generally available option for testing games was monkey testing, which was not particularly helpful because it rarely gets very far into the game to be useful. It also doesn't exercise the game as a human would. So you may not even care about the problems it finds. It's good for finding crashes on startup, but very little else. So before we get into some of the testing solutions that I'm going to present, I want to first introduce you to Firebase Test Lab. This is something I've been working on for about the last 5 years or so. Firebase Test Lab is part of the suite of application quality products in Firebase. It allows you to test your app or game in the cloud across lots of different devices, including some high-end gaming devices, and as of today, Android Q, and even Wear devices. So if you're building a game for Wear, then you can now test it on Test Lab. You can also test on iOS and Android, on physical devices, on virtual devices, in different languages or locales, and of course with different screen orientations. And you get comprehensive test results, including video and screenshots, and performance metrics, so startup time, most importantly for games, frames per second, and network and CPU and memory, all synchronized with the video, so you can see what's happening in your game at the time that you see some spike in some problem in your metrics. You also get crashes and logs and much more. Now, Firebase Test Lab is also the engine behind the Play pre-launch report. So how many of you here have you heard of or used the pre-launch report? Hands up. Not as many as I hoped. All right. Play pre-launch report is a free report. That's a free report where you get testing for free by simply uploading your game into the testing track within the Play Store. So take advantage of that. So we've heard from many of you that the security of your game is incredibly important, much more so than even for application developers. This is because the leak of a pre-production game would be absolutely disastrous. That is why we completely clean up the device between test runs, so that, in most cases, we're simply flashing the device. We also do a security check on the submitter of the game, as well as the game itself. So how much is this going to cost me, I hear you ask? Well, I don't hear anybody asking because it's a bit early in the morning for heckling, but it's going to cost you about $1 per hour for a virtual device and $5 an hour for a physical device. But the trick here is we only charge you for how long the test runs. We don't charge you for how long it takes to install it, to pull the results off the device, to ship them off to device storage, to post-process them, whatever. We only charge you. So if you send a test and you ask to test for 5 minutes on a Pixel 2, say running Android Q, it'll cost you about 40 cents, which is pretty cheap. So really, there's no excuse not to implement some automated regimen of tests for your game, which brings us to how you might go about doing that. So firstly, it's important to prepare your game for testing. So you can upload a special build to Test Lab, or you can build testability into your game. There's a special property you can check for that tells you whether you're running in Test Lab. Now, there are many things that you can do to make your game more testable. I'll talk about a few of them. You could, for instance, remove part or all of the game preamble, login registration, so you can get to level 1 pretty quickly and allow your test to focus on that. You could also remove randomness from the game so that your tests see the same game each time and they're not flaky. You could also start the game at a specific level, maybe increasing the experience of your characters or giving them artifacts so that you can test some of those later levels. So you can run lots of different kinds of tests on Test Lab. Some of them are targeted specifically at games. One test, which requires little, really no effort on your part, is Robo. Robo is a framework of different application crawlers that are used under different conditions. So when Robo sees an opaque screen, such as that rendered by OpenGL, it will switch to the enhanced Monkey Actions crawler. This is a crawler that uses machine learning to interpret what's on the screen and interact with those screen elements. Now, Robo shows a yellow circle, which you can see on the bottom right there, in the video whenever it interacts with the screen. So you can tell that it's about to click on the Let's Roll button, which is exactly what it needs to do to actually get to level 1. And as of I/O, and that's not going to be very readable to half of you in the back, but you can now run Robo locally, which means with this link, you can download a version of Robo and run it against your own games. And that's available to you as of I/O. With a little more effort, you can actually record test scripts and execute them locally or run them in Test Lab. Last year at the Games Development Conference in San Francisco, we announced a partnership with NetEase. NetEase is one of the largest game companies in China. They developed an integrated testing environment, which they use for testing their own games, and they made it freely available to anybody. They also open-sourced a couple of testing frameworks, including AirTest, which uses image recognition to interact with the games. They also open-source Poco, which uses instrumentation in the game engine to allow it to the test to interact directly with the games. There's support for Unity and Cocos and even the Android framework. You can record scripts with the game running locally, and then you can package them into instrumentation tests and upload them to Test Lab, where you can run them across a variety of different devices. And when the UI changes, as it always does, you simply re-record the tests. It's that easy. And thirdly, we have game loops. Game loops allow you to define critical user journeys through your game. You can do, say, one critical user journey, one game loop per level, or maybe one per character. And Mecha Hamster, which Patrick talked about earlier, and you can see behind me, has a built-in game loop. So check it out. And also, the pre-launch report that I mentioned earlier will preferentially run a game loop if it finds one in your game. So if you upload a game with a game loop in it to the Play Store, you get free testing of your game loop. So when should you use each of these different kinds of testing? So Robo's really good for testing the game preamble. It's also great if you don't have any tests yet. It's also used, as it is by some application developers, as a last-ditch attempt to make sure you're not doing something stupid as you push to production. So maybe a smoke test. Air test is good for navigating the UI and basic gameplay. And game loops, which test the same critical user journey each time, are really good for catching performance regressions. So now all you have to do is add those tests that you built to your CI system, and I assume you all have a CI system, right? So that every time you make a change, you can be much more confident that you did not break the game in some way, which makes your developers happy, makes your users happy, which is ultimately what we want. So now I've completely put you to sleep talking about testing. We're going to wake Jon up. Hey, Jon.
Thank you so much.
So how can Firebase help once you've pushed your game out into the wild?
Great question. So basically, at this point, you have your game built. You have your game tested. And things are fairly stable, let's say. What do you do? There's a lot of options, and I'm going to start with predictions. The reason I'm going to start with predictions is because it's so simple to enable. All you need to do is literally go to the console and click the button to enable it. From this point on, predictions will use machine learning to start classifying your user base into predictive groups. By default, it will start predicting who will spend or not spend and who may churn or may not churn. But this is fully extendable with any sort of custom events that you would like to add into your game. So what do we do once we have some groups that we want to target? A/B testing is a great place to start. Setting them up is super easy. All we need to do is first we need to select our target users. So let's say we use our predictions from the prediction service. And let's target our spenders, our potential spenders, because money is good. We like that. We next need to create variants, which are the things that you want to test, the changes that you want to test. We'll say that you have some remote configuration parameters that you would like to work with. Maybe you have some seasonal aspects within your game. You want to run a winter event because it's winter. And for our goal, we can say our potential spenders. Let's see who's going to get excited about this winter event, and let's see who's going to spend. With remote config, we can then deploy these changes if we find that they are successful. And we have our Hammy Snow Day event. But this is also, you don't have to go through an A/B test. So say we did this test, and you find out that seasonal events are great. Spring rolls around, and you know that these seasonal events are working. You don't have to go through an A/B test. You can go directly through remote config. You just change your parameters that you have programmed into your game, and you can launch a spring event, or summer, or whatever. Remote config is super useful, and this is barely even scratching the surface of the things you can do with it. So things are going great. You're making changes. You are gaining users. Stuff's happening. Maybe you're moving too fast. Maybe you didn't test as well as you probably should have. Or maybe just some edge case was discovered. This is about the last thing that you want your users to see. Within Crashlytics console, you get information such as the frequency, the device type, the OS version, really the who, what, where, when, why, and how many times your game has crashed. What's really useful is it gives you the stack traces, the likely stack traces, back to your code, so you can easily diagnose issues within your game. And as Patrick mentioned, you can also rig this up to alert you or your team, which is super useful. I would recommend integrating with Crashlytics even if you don't integrate with any other part of Firebase. It's super useful. And one notable point is that Crashlytics is now integrated with Unity. This means you can take your Unity game, and you can integrate directly with Crashlytics, get the same insights into your game as you would with a native application or really anything else that is outside of Unity. So this is super exciting for game developers. So maybe you've had some crashes, or maybe not. Maybe you just want to alert your users to some exciting news. Cloud messaging allows you to target your users in the same way that you would target them elsewhere. You could use your predictive groups if you want. You could send it to everybody. You could really target any other user metric that you have available. And I want to mention cloud messaging because it's just so straightforward. You target and you create your message. That's it. You send it. I should also note that these are A/B testable as well. So if you want to target a subsection of your user base, you can test out different variants of your notifications and see which ones are most effective, who's clicking on them the most. So with all of this, how do you know that things are actually going well, or maybe things are not going well within your game? Firebase Analytics gives you a bunch of insights, really all the insights that you would want into your game performance. Here we can see some mock data for Mecha Hamster. Things you can see in the analytics console include revenues, what countries your game is the most popular in, where your usage is coming from. And you can rig up really any other type of custom events that you have trigger within your game as well. So it's super useful for tracking funnels and things like that. So I'd like to invite my friends back up here as we have gone over a plethora? A smorgasbord of features within Firebase, just to kind of wrap things up and go over what we hope you have learned today. So we'll start with Patrick.
Yeah, as I mentioned, I really think that Firebase will help you shorten the distance from any idea you have to its implementation, and would encourage you to give it a chance even in a game jam situation.
And of course, I talked about a number of different ways that you can test automatically your games. So I really encourage you to take advantage of those.
And I have gone over just really a quick fire of available features within Firebase that I urge you to leverage and experiment with. There's so much provided out of the box that it's really worth your time to discover what Firebase can do for you.
A plethora of it.
A plethora. And with that will conclude our talk. Thank you so much for attending. Thank you, everyone, for watching online. And come see us in the Firebase and Mecha Hamster sandboxes.